Welcome all. Now I am going to discuss question number 21 from the GATE 2017 paper Set 1 Electrical Engineering. The question is, a 10-bus power system consists of 4 generator buses indexed as G1, G2, G3, G4 and 6 load buses indexed as L1, L2, L3, L4, L5, L6. The generator bus G1 is considered as slack bus and the load buses L3 and L4 are voltage controlled buses. The generator at bus 2 cannot supply the required reactive power demand and hence it is operating at its maximum reactive power limit. The number of non-linear equations required for solving the load flow problem using Newton-Raphson method in polar form is. To know the details of the Newton-Raphson method load flow problem, audience can go through the given NPTEL course or the video link. Let us have a brief discussion on types of buses in power system. In power system, buses are classified into 3 types: PV bus or the generator bus, PQ bus or the load bus, and slack bus. At PV bus, the known variables are P and V, unknown variables are Q and delta. At load bus, the known variables are P and Q, unknown variables are V and delta. So, from the Newton-Raphson method, here delta P and delta Q are the known vector and delta delta and delta V are the unknown vector. The matrix J is governing the relation between the known vector and the unknown vector. Here delta P is known, right? P is known at both PV buses and PQ buses. So the number of known P's are X plus Y. Suppose, let's say the number of PV buses are X and the number of load buses are Y. So, the number of known equations for the delta P is X plus Y. And the number of known equations for the delta Q. Q is known at only PQ bus, right? So, the number of known equations for delta Q is Y. So, the total number of non-linear equations are X plus 2Y. Let us solve the problem. In the question, it is given that generator G1, G2, G3 and G4 are the generator buses. And also it is given that L1, L2, L3, L4, L5 and L6 are load buses. Also, it is given that the generator G1 is slack bus and the generator G2 is violating its reactive power limits. So, it has kept its reactive power to the maximum value. So, it can be considered as PQ bus or the load bus. And G3 and G4 are generator buses only. Also, it is given that L3 and L4 are voltage controlled buses. Voltage controlled buses means V is known, right? So, it can be treated as PV bus. L3 and L4 are PV buses. So, the total number of generator buses are PV buses are G3 plus G4 plus L3 plus L4. This is 4 generator buses. And the load buses are L1 plus L2 plus L5 plus L6 plus G2 is also load bus, right? So 5 PQR load buses are there. Now we have to find the total number of non-linear equations. Total number of non-linear equations we need to find. So, from the Jacobian matrix, delta P and delta Q are the known vector. J is the matrix which is governing the relation between the known and the unknown vector. Delta delta and delta V is the unknown vector. This is unknown and this is known. So the total number of non-linear equations is 2 into number of PQ buses plus 1 into number of PV buses. Just now we found the number of PQ buses are 5 and PV buses are 4. So 2 into 5 plus 1 into 4, that is equal to 14. So the total number of non-linear equations are 14. The number of non-linear equations required to solve the problem are 14. Thank you.